Good afternoon and welcome. My name is Aaron Berg. I am the Vice President of Consulting Services here at Logic, and this is Data-Driven Decisions and S&OP, bringing reliability and speed to optimize scenario analysis. I have with me today my colleague John LeBoeuf. Very happy to have him with us. He's a consulting fellow at Spinnaker Management Consultants, and he will be walking us through some of the scenarios we'll look at today. Welcome, John.
Oh, thanks. Hi, everyone. Again, this is John LeBoeuf, and I'm glad to be here today with you. And I work with Spinnaker, which is a supply chain consulting firm we'll talk about in a moment. And the topic today is regarding S&OP, which is, as you know, sales and operations planning, and specifically how we can really leverage what it's meant to do around exploring business scenarios. So let's keep going. S&OP is really more than just supply chain planning. It's really the one place where the business can cross-functionally get together and consider business and strategic level decisions that actually involve multiple points of view, and it may involve working capital or fixed capital investments, and deal with what's really changing in its markets and capabilities. But the technologies that are often brought to bear in S&OP really don't always help the business enough to make decisions and evaluate strategies when there's multiple choices or possibilities in the future on the table. And so today, working with Logic, we've been developing an implementation of Spinnaker's closed-loop S&OP model using Logic's optimization and prescriptive analytics to really help a business codify and evaluate and make decisions about the important stuff in their business. And that's what we're going to talk about today.
Great. Thanks, John. So let's go ahead and talk a little bit about how this presentation will go. We'll do a very brief introduction of Logic and Spinnaker, so you'll know who we are. John is going to introduce a really exciting approach to S&OP, this closed-loop S&OP process leveraging the Logic platform. And then we'll go right into a demonstration of our platform and how the S&OP enhanced process would work. We'll show you a little bit under the hood, come back for a summary, and have some time for Q&A at the end. So to kick that off, a little bit about Logic. Logic is a leading prescriptive analytics vendor. We've been in business for quite a while leveraging optimization technology, that's mathematical optimization. And then recently, that optimization modeling capability has come to be part of Prescriptive Analytics, which really is an analytics tool that not only helps you understand what's going on in your business, but really helps you make decisions about what to do next. So it goes beyond just predicting, let's say, what your next level of demand will be, and more into, so what should you do about it? And we've been doing this for quite a while. And happily, our platform is one that John and the Spinnaker team have used to really create some good value. So let me click over, and John will tell you a little bit about Spinnaker.
Thanks, Aaron. So Spinnaker, first and foremost, is a very focused supply chain-oriented consulting firm. We cover all of the bases of supply chain management with a special emphasis in supply chain optimization and supply chain planning. And in the course of doing that work, we work with our clients everywhere from initial strategy and assessment all the way through redesigning their business processes, redesigning their technology that supports it, and we even go into ongoing business process and technology support. So we are focused on supply chain, but we're very much a womb-to-tomb organization, if you will, and we cover sales and operations planning and its collateral and adjacent processes very much in depth, and we have for quite some time. We've been in the business for about 16 years, and we're, cover a variety of industries, distribution, retail, consumer products, high tech. We're quite broad in terms of our industry support. We're quite broad in terms of our technology support, and Logic is really one of our key platforms for moving to market with technology support of S&OP. And I think it's S&OP that we should then maybe go do a deep dive on.
Okay.
So Aaron mentioned the Spinnaker framework for what we call closed-loop S&OP. And we call it closed-loop because it's one of the processes where you repeat it month over month, and there's a set of very strategic and operational decisions that have to be made, and many of those are considered over a period of several planning cycles. And one of the most important things about running an S&OP process is making sure that you're considering the same variables and the same facts and the same expectations for decisions that may be, sort of pondered over several months, and you want to make sure you're making the same decision each month for the same reasons. The model for S&OP starts with, and this is very typical, what's new in my product world, what products are coming to market, what products are sunsetting, and that moves into a demand planning where you're basically anticipating what the market will do with your products, both from a bottoms-up and a top-down point of view. Moving into supply planning, which is the production and purchasing-based response to your demand and how much of it can I support and how much inventory do I want to have as a risk and service management factor. And that moves into the final S&OP phase where I'm looking at how do I best balance my supply and demand to meet my business objectives. What are the various business questions that are being injected into the process each month? What's the financial impact of those? And then finally taking, the net recommendations to an executive level and making the decisions and living to fight another day. All of that in a perfect world is supported by good analytics and good metrics that provide that backdrop we were just talking about of consistency and completeness month over month. In terms of what we're trying to discuss today, by the time you get past supply planning in this model, it becomes quite difficult to express your supply chain capabilities in terms that lend themselves to financial interpretation. And it's also quite difficult to move things around on the fly to judge different scenarios. And it starts to be where many traditional planning tools run out of gas to come up with, given a set of starting conditions, what's the optimal answer to that? And so supply-demand balancing is a struggle at best to work with, stipulated assumptions that are hard to move in traditional planning systems. And what we really want to talk about today is how we can introduce some agility and some capability into the process of, making sure that your basic plan is trued up to what's truly optimal for your business, that you can talk about it not just in operational terms, but in business terms, and that you can define and introduce scenarios that play against that base plan and with some flexibility and efficiency evaluate them and have their merits and demerits expressed in the same terms and the same metrics as your base plan so you can make decisions on what's productive and promising for your business. So that's the closed loop S&OP model we're working with. And today when we start talking about the demo, we're going to start with that box in the center called constrained supply planning and make sure that as we move from that into demand supply balancing, that we're making the best decisions possible to get to our starting point for completing the S&OP process. So if we move on to the next slide.
Sure.
So Aaron, I'll introduce this if you don't mind. So the first thing we want to do is diagnose what's going on with that starting plan that we're probably sourcing from a planning system of record that could come from several vendors, or it could even come from spreadsheets, but we've migrated it into River Logic where we can also plan. And so we'll diagnose what's going on with that plan and refine it to optimality. We're going to be testing it for profitability and service level targets, which is already difficult to do with traditional systems. We'll investigate, some exploration of can we use alternate production, can we use overtime, and what is the actual dollar trade-off between profit and service. And then we'll move into a couple of scenarios which kind of evoke what S&OP is all about. And in this case, what we've chosen today is first off, and this happens in consumer products quite a bit, if you open up a potential new sales channel, and we're sort of modeling some sort of warehouse club that hasn't carried our products before but now may. And then also we've got a potential plant closure that's we may lose a significant chunk of capacity for a quarter, and we need to understand what how the business could adjust to that and how much the business will be impacted or impaired, or what we could do to prevent that impact. So that's what we're going to demonstrate today. As Aaron moves into the actual live demo, I think the first thing we're going to want to do is show what plan are we starting with, what assumptions are built into it, and what are we going to do with it.
Sure. And John, can you give us a little bit of background on where we're starting? Where are we in the process right now? Have we already gathered our demand? Have we done an initial supply plan?
So if you think back to the diagram, we do have a demand forecast, and we've pretty much bought into that as a base forecast. And the supply response we've created to it has been a supply response based on the configuration of the core system with what we would consider the default options, which is we are averse to overtime and we're avoiding overtime. We would like to run our products on their primary assigned lines and avoid shifting products off onto other plants if it's not necessary. And we're basically running the vanilla line, if you will, and we're not really leveraging the alternatives. Our planning system has some capabilities, but not complete capabilities for intelligently deploying those capabilities. And so we're starting with the baseline just to understand, what we would do with our basically our operational defaults.
So, John, that very much sounds like a sort of traditional, maybe even an endpoint or a midpoint for an S&OP process. Is that correct?
Yeah, we're right at that point of that constrained supply plan in the middle, but the constrained supply plan still may have a little bit of life in it. It's just that in a traditional planning system, we don't have all the insights and metrics that we can use to judge if those alternatives are being used profitably or wisely. And so we've moved into the River Logic environment with the same planning data. We've migrated it directly from the planning system of record, and that's actually where this data comes from. And what we're going to do now is, with the presence of those profitability and service metrics that you see in the upper right-hand corner, we're going to start exploring some alternatives and have some insight in whether they're helping us or hurting us. So if you look at this initial supply plan, a couple telling things. There's a certain profit margin there, and what we're seeing is that we're showing net sales of $1.75 billion, but in that top center graph, you see that there's a bunch of demand that we have not been able to support, and the production equivalent of that on the upper left shows that there's demand that is not matched by production. And then if you look at the line utilization in the bottom center, one of the first things we realize is that Plant 7 is not being utilized at all, which suggests that it's not the primary or preferred plant for any products, but it represents latent capacity that, of course, we would want to consider using. And that service level of 85.8% is far, far below what we would aspire to for our business. So one of the first things that we want to do here is evaluate, well, what if we loosen the reins a little bit while keeping a very close eye on profitability and end up with what we would consider a more acceptable supply plan that comes from, as you look at the labor and line utilization down below, a couple things we've changed. And Aaron, you may want to explain what we did in the model between these two scenarios to reflect that difference.
Sure. So in this case, the model is considering beyond the primary or the normal routings and allocations to the production facilities, and it's now looking at all the different ways that it can route and produce and finding the way that satisfies as much demand as possible at as low cost as possible. So it really is looking at not just one scenario, but it's looking at hundreds and thousands of scenarios, different ways that you could allocate demand to the production facilities, and coming up with this solution right here that it's suggesting.
So in the context of how we do this in River Logic with the dashboard that we have, we really got our eye on that upper right, where we see that not only did it improve our profit while it was increasing our sales, it even improved our profit margin. And so this loosening these purse strings and loosening the restrictions on lines and routings and labor is actually quite profitable. And so we feel we have some assurance that those decisions didn't just turn something into a cost center, is that they did in fact add to profit. The one thing that we look at here, this is very close to a pretty good plan, but that service level there is still shy of where we want to be as a business, which is at 98%. And so one of the things that we can do in River Logic is we can optimize for things like service level, but we can also introduce them as a constraint while we want to continue optimizing to profit. And so if I introduce a constraint which says, do what you can, but keep the service level to 98%, we see very quickly that we got our sales up to $2 billion. We have very little left on the table in terms of unsupported demand. Both line and labor utilization are still pretty healthy, and we've got the service level up to 98%, but only just. And in the process of doing that, we had to concede a little bit of profit, but very little. We see that in order to get to a service level that meets a business target, we gave up, went from 144 to 143 million in profit. And this is a case where you can't simply optimize to a single objective, but optimizing to blended objectives is quite difficult, and the ability to introduce an alternative dimension of objective as a constraint or a floor is actually really valuable in a business sense. And so what we have now is we have something that we believe is a candidate for our base plan of record, if you will, before we get into evaluating scenarios. And it's not just a dashboard. There is actually quite a bit of data behind this. If you look at the production plan, we see that this has a complete line-by-line production plan that rolls up to that total production. And we could actually drill further down into this and see which products are loaded onto which lines. And so there's the detail that you would need, like you would get from a traditional planning system, to actually submit plans of record to the line. And for example, if we wanted to freeze period 1, we could take that period 1 column and release product level work orders to each plant according to this. So, and it's also exportable into business intelligence and other environments. It can be further processed in the Power BI environment as part of River Logic. And so we've optimized it top down from a business sense, but the bottoms up detail is still there. The same is true if we go back to the dashboard and look at some of the detail that we have on our line utilization. We can pop down through there and see that we've got line by line level plans that we can then forward to manufacturing or production base and let them start to prepare the collateral work that they need to do, like preparing workforce and technician and maintenance schedules around this. And so again, this is a pretty complete plan, even though we were able to build the plan on the basis of top-down business metrics. So if we go back, go ahead,
John. So now we've created an optimized plan, and then we said to our optimized prescriptive plan that we want to meet a minimum service level. So we've given back some of our optimization in order to achieve the service level with all the details and results that you just showed. What's next?
Well, we've got a couple questions that came up in this month's S&OP cycle, and the first one is there's an opportunity to go introduce some of our products into a new channel, which is one of these big warehouse clubs that sells high volumes of a few products at a discount. And what they've done is they have selected, they've cherry-picked out of our products because they like to sell a small number of very popular products. And to do that, we're going to, and it shows the first sales of this starting to go in period 6. But in advance of that, because it's a brand new channel, we have to populate their distribution pipeline, which means we're going to have a spike in demand as we go into this, and then a sustained increase in demand for the selected products past that point. When we tried to solve for this originally, we had a just-in-time flag, if you will, placed on the solve, which basically didn't like to produce inventory very far in advance of the demand that would consume it. So we had a model. That inventory graph, if you look over on the lower right, on the previous scenarios, was quite flat. It maintained a very flat inventory, and the inventory delta month over month was effectively zero because it would produce just in time. The spike in the demand for these products was so significant that we couldn't get a feasible solve with that restriction in place. So what Aaron did here was eliminate that restriction and permitted the optimizer to pre-build inventory where it made sense. Now, and you can see that we did get a feasible solve. We added 50 million in sales to our 2.05. We maintain our service level at 98% because we're continuing with the constraints in the model otherwise of the base plan. And we see that it added to our profit as well. But the other thing you see is that if you look at the bottom right, that we basically had to pre-build a little bit of inventory to get it in the pipeline in advance of when we shipped it to the customer. So in period 4, which was earlier than we're going to send it to the customer, we actually did some inventory build, and then we drained it as we started populating their pipeline. So what we're able to do is optimize inventory pre-build, which is something we normally would resist doing until it was absolutely necessary because there is a cost of carrying inventory, and there is a risk of demand, uncertainty. We would prefer to build it as close to the demand as we can so that we wait until you see the whites of their eyes, if you will. And so what this model also did, by loosening the inventory restriction, it also found a more optimal future plan. You see that way past where the period 4 spike in the new channel, that it continues to modulate inventory a little bit because for optimality purposes, it found that that was better. And you can see that the net income that it optimized to overall was actually higher than our base plan, which suggests if we go back and think about our base plan on next month's cycle, we may consider loosening this restriction, even for the base plan. But again, we're a just-in-time manufacturing outfit, and we're resistant to it. But in this case, it was actually necessary. And so in order to create a scenario like this where a subset of products has a potential additional demand, we need ways, and this is where RiverLogic excels, to be able to efficiently introduce those kinds of bulk factors into a planning environment. So what we've done here is take the base demand, and I'll let Aaron explain how we've sort of flagged the selected products and modulated their demand to reflect an alternative scenario that actually uses a different demand stream otherwise against the base data.
Sure. To show you how we did that, John, I'm opening up our online interactive planning platform. And what you see here is a list of the scenarios that we ran for this particular demonstration of the S&OP process. So you can imagine that, let's say, each month a planner is coming online, creating new scenarios, updating data, whether the initial supply plan, the approved supply plan, and working through this process of S&OP. Once I'll drill into one of these scenarios. So if I go into a scenario, for example, the new channel demand scenario, I can see I am presented with, it's actually a number of grids where I see products at locations, and we've got this set up to allow the user to change and adjust the products that are part of that new channel. So right now, we're now including product 9045391, and maybe the product above it, into our new channel demand, save that to the platform, and then go ahead and adjust and set how that new channel demand is going to grow, let's say by time period. So one of the very powerful aspects of prescriptive and optimization planning is that you can set minimums and maximums for certain activities. So I could say that, for example, new channel demand, if the production were available or inventory were available, could grow, let's say, by 100% over the next several months, but it would have to grow a minimum of, let's say, 25% in order to meet my desire for growing out a product. And those can be set in here as a minimum maximum factors, which would change for each month as I grow out that new channel demand. So John, you can see right now, we've set in month 4, for example, that we're going to grow all of those products above the forecasted level that are in that new channel by 25% to as high as 100%, which is 200% of the base demand, is what we just set.
Yeah, and if you look at period 5, in order to get started with this customer, I mean, even though the sustained increase in demand is about double, we have to populate their pipeline. So there's a big spike in period 5 where we have to ship a ton of stuff to fill up their distribution centers, their retail shelves, and their transportation network. So that was the problem we were trying to solve: is how do we get over the blip, and how much inventory do we really need to pre-build here?
Right. And then in addition to saying how much, I have the option here of putting in other information about the demand. I could set pricing. I could set where that inventory is being stocked, how much I'm willing to hold in inventory, as you can see. So we have a lot of capabilities. Now, once the analyst has made these settings and adjusted that scenario, I then save that and can re-optimize. So remember the prescriptive engine that we talked about, that optimization could be looking through hundreds of thousands or millions of different ways of answering that new channel demand and looking for the ones that come up with the best profit that meet the service level requirements, et cetera. And so the user would come in here and would click some adjustments or any other changes they want to make to the scenario. You can see there's our new channel scenario. There's a couple of other settings I'll show you inside of the scenario. I can, for example, adjust a lever. If we click forward to change the objective function or change the start date of the analysis. I can drill into some of the planning options that I have of whether or not I can allow, or I'm asking the model to optimize which production routes to use, what the minimum fill rate is, et cetera. So John, this gives us a lot of power to build and run what-if scenarios and optimizations that have different parameters to them so that we can continue our investigation.
Right, and the one you just finished with, where we set that 98% service floor to as the constraint for service level, that's an obvious place where you could interrogate your model to see how costly it was to move to 98.5, 99, or how much benefit there would be from dropping it to 97. And I think we're going to get into this later, Aaron, but the question is going to come up when we talk about what the technology does to let this happen is the performance aspects of it. So let's bear in mind when we come back to that to talk about performance,
Sure.
where an analyst could usefully do these types of interrogations and iterate their planning questions.
Yeah, I mean, I'll just mention right now that we hit the solve button. This will re-optimize and look through all of those hundreds of thousands or even millions of possibilities and come back with an answer in just a minute or two. It's really, really incredibly powerful. I think what I'd like to do is go from this web-based user experience. This is where our analyst is going to be really building and creating the scenarios and then looking at results that we saw earlier, to show you a little bit about what actually is happening behind the scenes. And let me flip over to that. Hold on just one moment. Okay, what I've brought up right here is RiverLogic's modeling platform. This is where the designer of the system, so the designer of the S&OP process and process model, John, that you were showing earlier the results from, would draw the picture of the supply chain or of the business that they're doing. This is a modeling platform which is visual, so the user draws parts of the business process they want to include, and I just, for example, added the ability to purchase more manufacturing hours, or I could even purchase some finished goods. I'm adding to the model like this. So this visual modeling system allows us to model lots of different kinds of businesses, from very simple supply chains to very complex ones. And what you're looking at right here is the actual model that is underlying the demonstration that you were just given. And you can see this model represents both labor and production hours. Those production hours are consumed by manufacturing processes, and the manufacturing processes result in finished goods being delivered to inventories that are then demanded by sales throughout the demand region of the model. And John, these are objects that actually have underlying data in them. So let me pull up some of the underlying data from this conversion object. This is showing some of the underlying data inside of that conversion. This is where the manufacturing is happening. And you can see I have a number of tables. These are all the different things I can define about production. And I'm going to zoom in on just one of them, which is the list of different production facilities that I have. So here, just inside this one object, I can represent all of the different production facilities across all of my locations that are available to do production. And I can make I can add data about them. They could be constraints, how many hours it can run, how much does labor cost, how much is the fixed cost each month of production, things like that.
Yeah, this is actually one of the really powerful features of RiverLogic as used in supply chain planning, is because these types of conversion models are very consistent with the standard supply chain advanced planning system model of flows, routings, multi-step or single-step, and the associated constraints and resources that are consumed. It's very straightforward to map directly from the assumptions of a traditional planning system into this type of model, both in terms of resources that are used as capacities, resources that are used as inputs like materials, and extend that even further, because the one thing I'd like you to touch on a little further here, Aaron, is how this ties with those little P&L icons that you see at the bottom.
Sure. So let me close this object here, and I'm going to click the P&L icons. That's what John's referring to down here, represent the financial entities in the model. So if you think of the top part of the model as being operations, and you think of the bottom part of it being the financials of the model, you see that we've represented two financial entities, manufacturing and sales, that roll up into the corporate financial entity. And each of these financial entities is actually a full accounting set of books. It's got a full general ledger inside of it. So if I click on it very quickly, you'll see here's my chart of accounts with all my account names, account balances. I'll click out of that pretty quickly because it's a little bit boring, but you get the idea. Now, every activity that happens within the model, whether it's paying for labor, whether it's paying for manufacturing costs or shipping costs to the inventories, or revenue that's happening from meeting a demand, all of those financial activities in the model are reflected in the appropriate general ledger line items in those financial objects. And this is very unique to RiverLogic, that you can then ask some very sophisticated questions and set some very sophisticated guidance to the optimization, to the prescriptive nature of the tool. For example, you might want to set the objective function, set the model to try to maximize your profit, and it would know how to calculate profit by knowing all those costs and revenues. But you might also want to set it to maximize net present value, or minimize costs, or maximize pre-tax income even, something fancy like that. So there's a lot of power in having that financial capability within there.
Yeah, and I think the voiceover to that is that these are not just proxies for those types of values that come with some optimization tools where a modeler has to invent what they consider to be a reasonable approximation of profit. It's actually being built right out of the the P&L and the set of books. So the financial statements are pretty good analogies for the actual books of the corporation in this model, and all of the definitions are consistent, such as pre-tax profit. And so this is basically extra work that you don't have to do to apply monetization metrics and considerations to a supply chain plan, which at the S&OP level makes it incredibly valuable. And all of those are available to your objective functions, and you can constrain this or set objectives according to both the operational and the financial considerations. So it's actually possible to model and optimize based on line stability if that happened to be your key objective in a given set of business questions.
Yeah, absolutely.
And the other thing I'll point out is that the manufacturing, which is a process and conversion thing, can easily be a multi-step manufacturing level separated by additional inputs or values. And the inventories can also be represented as a network, if you will. And so, the complexity here can be pretty arbitrarily managed. And one of the first questions that we've gotten from people watching the webinar is, this is a visual modeler, but when you start to work at scale, you would like to be able to, pipe data into this model in bulk using, integration strategies. So, Aaron, maybe this would be a good time to discuss what are the typical sources of data and what sort of typical processes and models do you follow to integrate data inbound to this model, when you start to work at scale.
Sure. John, you talked earlier about our starting point for the model for the analysis we showed earlier was the system of record, the operating systems that have, for example, in manufacturing, the ERP system might be the place where the production routings of record are kept. In that case, and actually in the case of this model, that data is refreshed as needed. So this is really the S&OP analysts, deciding when to update the production routings, and as long as they're kept up to date within the ERP system, they can be connected directly in and pulled in on demand. Some of the other data that we see refreshed frequently, certainly current inventory levels. So as you start a new planning process each month, you'd want to know what your current inventory levels are. Any adjustments to costs of labor, raw materials, et cetera. So those are other cost data that can get updated fairly frequently. And of course, the thing that drives it all at the end of the day is the sales demand. So the initial demand plan will be updated surely every planning cycle. And those connections to your internal data, we have just a huge number of ways to connect because we're based in the cloud, and we use all of Azure's and Microsoft tools available. But one of the common ways is to pull data directly from SQL Server. Others connect with spreadsheets, and we can also connect certainly to other specific tools and reporting tools.
Right. And in terms of the type of master data, the configuration that, for example, that assigns products to plants and things like that, it's very consistent and well aligned with the standard data models that you see in traditional planning systems. The ones that, once you set them, it's hard to play what ifs with them, but the starting data is actually quite comparable in its modeling constructs. So exporting from SAP APO, for example, is a very common and relatively straightforward thing to do. There's not a lot of reinterpretation or transformation required to use the same data for the same purposes with the same basic data relationships. I think it's worth a discussion of the line and hours thing here, because we've got a final scenario to discuss where we are contemplating a plant shutdown. And in this model, Aaron, maybe you can show them kind of where we would go in and model that type of data, and then we can go back to the EO Plus interface and see what the system suggests we do about that final scenario.
Sure. So in this model, the manufacturing facilities are represented right here, and I showed you the list of those before. What I didn't show you is that the manufacturing facilities actually are able to be managed on a time period basis. And what I mean by that is if this model is looking out, say, 24 months for planning purposes, you would want the ability for each month for a particular plant or a production line, for example, to be able to view the resource availability of that line for each month. So as part of your planning process, for example, you might set the number of hours available different for each month. Maybe you'd have a shutdown, on that plant in these months. You'd bring the line back up here, et cetera, et cetera. So in the model, the data would be here where you would adjust it. But once that model is installed into the cloud system as part of the cloud system, you'll have the user interface that we were showing you before. Okay, now we're back to the data we were looking at before. John, do you want to set the stage a little bit for this scenario?
Yeah, well, we've got a problem in one of the plants that we have to understand what we may have to do as a business if we need to shut it down for a quarter to bring it into compliance. So this hasn't happened yet, but we're looking out in period 4 and beyond, potentially having to shut down one of the plants. And what you see in the lower left after we've solved this is plant 7 is the plant in question, and there's a chance it may be out of commission in periods 4, 5, and 6. Now, if you remember, we had, for the channel demand, had previously lifted a restriction in the solve that was driving just-in-time inventory, and we allowed inventory to float and basically pre-build as part of the optimization. And so the question here is, would that, lifting that restriction and separately from the channel demand, allow us to cope with the loss of a plant-level capacity for a full quarter? And what we see here is you look at lower left, and sure enough, plant 7 was taken offline deliberately using the data tools that Aaron just discussed. And we see that we're still preserving our base plan $2 billion in sales. We're still preserving our service level. We had to concede another $3 million in profit, and we cost us a little bit in our profit margin, our percent of sales. And if you look at the bottom right, you see that the system did, in fact, go and pre-build quite a bit of inventory in advance of the shutdown and then drained it during the shutdown and then came back to equilibrium when the plant came back online. And so the answer to the business is it'll cost us a little bit in terms of profit, but we're not going to short any customers. We're still going to maintain our overall revenue. We're going to maintain our overall service level. And, so you've taken a very detailed operational decision here that has major business impact and very quickly resolved the question of, well, how much impact does it have to the business and in which ways? So basically the answer here, it's going to make us slightly less profitable, but it's not going to cost us any sales and it's not going to cost us any customers. And so, again, go ahead, Aaron.
One of the things I wanted to point out, and this is really the nature of prescriptive analytics, is that it, as you mentioned, it does that inventory pre-build because you have that scheduled shutdown, but it's doing it in the best possible way. Now, what I mean by that is I'm sure that you could, very easily with a shutdown say, hey, I'm going to lose 3 months of production, so I need 3 months of production. I need an extra month in every month before that. But really, that may not be the best way to do it. That may not be the lowest cost way to do it. So with the optimization, what the prescriptive tool has done here is looked at all of the loadings on all of the lines to see where it can best fit in that production and how to time it in the best possible way, really so that you would lose, in this case, the least amount of profit. So really, what's the best we can do in a bad situation?
Right, and one of the things you'll notice in the bottom center on line utilization is that we are basically, it appears that we're overdriving some lines, but those lines are based on the standard calendar, and this is sort of a guide to which lines are we going to have to add shifts to or work into overtime against their nominal line calendar. And so, again, if we drop down into the production plan or something like that here, we can see where the where the production is shifted around. If you scroll down and select plant 7, we'll see that we basically zeroed out periods 4, 5, and 6. And the fact is, if we were to compare this, if we had a side-by-side net delta, we would see, compared to the base plan, which lines were picking up additional volume in which periods compared to the base plan and the shutdown plan. And so this is a planning process that really speaks to the importance of having the same way of evaluating a situation from planning cycle to planning cycle, because we do not yet have to pull the trigger on making this decision. Although we do see that even in period 1, it has implications compared to the base plan for additional production. So, we may decide to hold off one more period to commit to the additional production at other plants because we don't yet know if we have to shut this plant down, but we're running out of time here. And so the other value of this is that it will tell you if the optimal plan says you should start today, and it will also let you evaluate, well, what if I wait to make this decision? Will waiting a month still be feasible? And if it is, how much more what's the cost of waiting? And so the ability to do optimization in this case is just, I just can't emphasize enough how much power it gives to your business to consider, what should I do and when do I have to do it? What is the point of no return? Okay. So, Aaron, I think we can finish up with the scenarios here. We've shown, how we can drill down into the production plans that result in the utilization. And let's talk some more about, how this plays into S&OP. So again, there's a set of business decisions that really belong in S&OP. Those are the things that where you may have to make high-level, plant or line-level decisions that affect workforce, that affect your financials, and may affect sales and customers. And the best way to do that is when everybody's got a seat at the table and the tools and the measures you're using to drive those decisions are consistently applied period over period, so you know that you're making the same decision this month that you would have made last month if you were presented with the same set of facts. And the ability of River Logic to do that by having, being able to define those metrics and maintain consistent dashboard, but also by use of optimization that considers both the operational and financial impact of what you're doing is really kind of ideal for an S&OP type environment. And that's kind of why Spinnaker is working with River Logic to, play out the S&OP process. And so, to be able to quickly incorporate scenario analysis in your S&OP process without delaying it or adding friction and inertia to it is a really incredible advantage. So, Aaron, do you have any additional comments you want to make on how we pulled this together?
Well, first off, thank you, John. This is really some great and powerful stuff, and we look forward to our customers and partners really getting some terrific value out of this. I think we may have a couple of questions that came up. John, do you see the question screen in front of you? Anything?
I think the first one is can we talk just briefly about the flow of data into this model and what's our starting point, which we've touched on already. But once we've finalized a plan, what kind of outbound integration are we capable of with the planning results that we've got here?
Sure. I think one of the things that you showed, John, as we were walking through the scenarios is that the system creates a plan all the way down at the level of detail of each month, each line, each product, what things happen where. So, for example, a production allocation plan that you showed several times during the presentation, typically that plan, we would call a playbook, is integrated back into the system of record so that it can then be executed upon in the S&OP system of record. So that could either be into that sort of tool directly into operations, and in some cases people output them literally to spreadsheets and then go from there.
Yeah, I can think of a couple of specific scenarios where I'm familiar with how we would integrate this. One is when I have a plan that I've judged to be my final plan, and if I'm an SAP ERP user, I can export this back into the ERP environment as the set of planned orders, the plan of record, if you will, that would then be used by the ATP or GATP functions in SAP, which is what's used to take inbound sales orders and promise them against available supply. And you can do that either on an inventory basis or on the basis of planned future supply. So this could easily feed the GATP supply statement that would be used to promise and schedule orders that are inbound from customers.
Absolutely.
The other is that at the very leading edge of this, you can actually take like period one's detailed plan and introduce them into SAP ECC as production orders and actually use it to drive your factories. In other words, you could closed loop integrate this with ECC as a way of directly instituting work orders and, for that matter, purchase orders for the modeled, purchase material. And then finally, you can introduce it into the other systems environments you have where you deal with workforce planning and workforce issues, as well as your preventive maintenance and things like that. Publishing this line loading plan to the production facilities so that they could plan their PMs around it. It's also very useful. Finally, I would say that the analytics and the high-level analysis, it's possible to model the financial books here in a way that they're aligned with the FP&A systems of a company. So if I'm using something for my quarterly budget tracking and things like that, this could feed directly in here. And finally, when you go through these scenario analysis, if somebody says, you know what, it's time to pull the trigger, I want to assume that I'm going to get this new channel demand, therefore I have to start building now or else I'll run out of time, is that all you have to do is flip the switch, adopt that as your scenario, and even though the demand plan has been altered on the RiverLogic side, you can still submit production order plans to your factories based on decisions you made in S&OP. And so the ability to, codify these various scenarios and then denominate one as your working plan of record is very useful in terms of that outbound integration into systems that go and execute your business.
Absolutely.
So another question that comes up is one of what expectations should I have about performance? If we're contemplating using this where an experienced modeler is actually able to set up and interrogate various scenarios, what sort of system performance things should we expect, and what kind of scale would you refer that to? In other words, if we have thousands of products and dozens of lines and we're planning over several dozen time periods, Aaron, maybe you could talk a little bit about, just the performance expectations that we can have with RiverLogic.
Sure. In the scenarios that we were playing with really are real-world scenarios. So there are, I think, some 1,000 or so SKUs that are important to plan all at once because they share production facilities, they share distribution, as well as some aspects of demand. In that case, planning 24 months, thousands of SKUs, as you saw, 90 different production facilities, is well within the capabilities of the cloud platforms that we have. The cloud platforms are very scalable. In this case, this model just takes a few minutes to solve, but we've seen larger models that take maybe 10 minutes to solve or a bit longer. We've also seen models that include additional complexity beyond what we've shown in this scenario. And now that is significant because the modeling system that we showed you, that ability to draw pictures of your business, really allows you to be very specific on the parts of your business that are important to you. And that could be different in every industry. So, for example, in one industry, it may be very important to model the multi-level production and all of its production steps because there are some complex constraints in parts of that process, whereas other industries may have much simpler production flows. So you can have performance from just a few seconds to a few minutes to solving these scenarios to tens of minutes or 20s of minutes if you choose to add a lot of complexity. And often that additional complexity is worth the small amount of extra time to really look through lots and lots, millions and millions of different possibilities of best solutions for optimization.
Great. So we're nearly out of time, but there's one kind of final question, which is what we've just showed here, what is it? Is it a demo? Is it a working application? Is it just sort of mocked up? And the answer to that is that Logic and Spinnaker consider this basically to be a reference design. Obviously, the plants that are represented will have to be replaced by your plants. The SKUs that are represented will have to be replaced by your SKUs. The various key materials and resources that are consumed, like lines and labor and purchase goods, will have to be adapted to yours. And the various stages of manufacturing or conversion will have to be adapted. But it has all of the basic blocks of a working supply chain planning model that are directly translatable to the equivalents in your business. And so we would present it as a reference design that would be our template for adapting it to your business while preserving the various features around the P&L and the objective functions that are built into Logic and the constraint management that we can do. And again, knowing that our models of resources and materials and demand is completely commensurate with what traditional systems typically set that up in terms of the data model. The definition and integration of that is work, but it doesn't involve a great deal of uncertainty. So we think we have something where we can map it into your business and do a solve for your questions and your scenarios and your sets of realities in a way that's very consistent with what we've shown you today. So with that, Aaron, I want to thank our viewers, and I'll leave it to you to say your final words, and we'll close it up here.
Great, thank you very much, John. It's been a pleasure and working with you and getting the benefit of some of your great experience and seeing how it plays out on the Logic platform. We'd encourage anybody with questions to reach out to Logic. We've got a couple of email addresses on here, both for Logic and for Spinnaker, if you'd like to reach us. And look forward to seeing you all the next time we put together a webinar.